Okay, question number 1 has been a unit exam question in the past, as has question 3. Okay, that has also been a unit exam question. It's a boat question. Okay, and that's it. The other ones are a bit more involved than I would ask on a test, but those 2 have been exam questions in the past. So give you some idea of what I might ask. Okay, so let's just quickly look at the diagram for 1 here. Okay, our first line is 25 kilometers at 20 degrees north of west. So there's my reference line west, okay? And I'm going to go 20 degrees north of that, which is a pretty shallow triangle like so. Okay, so this is 25 kilometers long. This is 20 degrees. Okay, this will be the y component and the x component of the black line. Now my next vector is 10 kilometers south. Here's the tricky thing about that. Scale is important. Okay? 10 kilometers is less than half the length of that 25 kilometer line. But that 25 kilometer line is not angled very much. So this 10 kilometer vector is actually going to end up down below where I started. Okay? I mean, if we're just looking at scale here, that's less than half the length of my 25 kilometer line, I think you would agree, right? And that's just roughly to scale. I didn't bother measuring it, okay? But I do know for sure that this line has to go below where I started simply because of this angle. And I can confirm that before I even draw that by simply calculating what y is. And that's what I actually did at my desk. Okay, so I went y equals, okay, the sine of 20 times 25. Okay? I don't remember what it was. Let's calculate it again. I feel like it was like 8 point something. 8.6? Yeah, okay. Calculator today? I was using that just a minute ago. All right. 8.6 we're going to say, just because my calculator doesn't want to work. Okay, so this comes out to 8.6 kilometers north. Well, 10 is longer than 8.6. So from that number, I know I've got to draw my 10 kilometer line a little bit longer than the y component of my first vector. With me there? It's just a simple way to double check. All right, that means my overall resultant looks like this. Okay, here's theta. That'll be my overall displacement, green x, green y. Okay, and I can go from there. Okay, questions on that? All right, so for number 1, okay, I need to get all of the x's and all of the y's so I can move towards getting the sides of my resultant's triangle. So first thing I've got to calculate is the x component, because I already calculated the y, for the 25 degree triangle. So this is the x component right here. Okay, so black x is that side there. It's adjacent to the 20 degree angle, and I have the hypotenuse, 25. Okay, so when I do that, I'm going to get like 24 point something. Okay? So cos of 20 times 25. Right? Oh, I'm in radian. Forget it. Hang on. I gotta clear that. Load. Degree. Degree is better. Okay. Cos of 20 times 25. Okay, so 23.49. 23.49. Okay, and that's kilometers west. okay? And obviously I've already calculated the y. So now I look at my red line, my red vector here, and it's due south. So its x component is 0 because it doesn't go east or west, okay? But its y component is 10 kilometers south. Because that's all it does, it just goes due south. Everybody follow me so far? Okay, so our next step then is to calculate green x, okay? My resultant's x. Well, that's really easy. The only time in this whole trip where we went east or west was in the first vector. So this 23.49 kilometers west is all I do on the x-axis. Therefore, green x is 23.49 kilometers west. Okay, now for my y, in the black one I go north, and in the red one I go south. So I'm going to have to subtract those because I go a little bit up and then a bit back. So I'm going to have on that the 10 south minus the 8.6 north. And I should have both those values in here. Okay, so I'm going to have my 10 minus that number there. Right, so we end up only 1.449, so 1.45 kilometers south. Okay, so now I've got green y and green x, so I know two sides of my resultant's triangle. Right, so now I can calculate d using Pythagorean theorem, so that'll be 1.45 squared, obviously with all the decimals, plus the 23.49, again, with all the decimals. So, square root of that squared plus that squared. Oh, I multiplied them. That squared plus that squared. All right, so I get 23.5, which to two significant digits is 24. Yeah. All right, that's the magnitude of my displacement, but I also need to calculate what direction that's going. So theta is going to be tan to the minus 1, because I'm going to use the opposite side, y, which was 1.45, divided by the adjacent side, x, which was 23.49. Okay, and that will give me second tan of that number divided by that number. Gives me 3.5 degrees, and that is south of west, okay, because it's touching west and going south of it. Okay, everybody all right with that one? Okay, keep going on the other ones here. Okay, let's see how we do. I'll draw the next one here in a couple minutes. Okay, so on this one, here's what they're telling us. They're telling us that a plane is flying at an angle into a wind blowing 75 kilometers per hour due west. Okay, so we got a wind that's doing this. Okay, it's blowing that direction. Okay, due west. The plane ends up going due north. So our resultant actually ends up doing this. Okay, and that's 318 kilometers per hour. So what direction is the plane flying? Whoops, I drew that wrong. Hang on. Okay, now you're probably looking at that and going, Coderre, you just put those head to head. Yes, I did. Remember, this blue line is our resultant. It is the product of what the plane is actually doing and the wind. If the wind is blowing due west and I want to end up going straight north, I actually need to angle into the wind, just as the question indicates. So what they want to know is, since you obviously have to be doing this, what's your heading? What angle into the wind do you need to fly in order to end up going due north? Okay, so it's tricky wording, right, on that one. So on a question like this is a going across the river question as opposed to rowing across the river. Okay, it's just with a plane instead of a boat. Okay, but our resultant is due north. Okay, that means it's not the hypotenuse of the triangle. Okay, and we have to find something else. So now we're looking for this, knowing that the blue line is 318 and knowing that this is 75. Right, we can figure out what that angle is. Okay, and all we have to do to calculate that angle, right, is go tan to the minus 1 of the opposite side, 75, over the adjacent side, 318. And when we do that, we get 13 degrees east of north. Okay? So that one's not nearly as involved, okay, as like a vector components question, because it's really just a boat question. Okay? All right. Number 3 is also a boat question, but it is a rowing across question, not a going across question. So in a rowing across question, you end up downstream. Okay? Your resultant is the hypotenuse of the triangle on one like that. All right? Give you guys a few minutes to work on that one. Okay, let's have a quick look at this one here, guys. So with this boat question, okay, we have our river. Our river flows at 1.6 meters per second east. Okay, and we're rowing at 4.0 meters per second north, according to the question. That means our resultants, so if somebody was watching us, from a drone directly above the river, they would see us following this green line. Okay, that would be our resultant velocity, and that would have this vector. Okay, so that's all that part A asks us to find, is just the hypotenuse with its corresponding angle. Okay, so our average velocity will simply be the square root of 1.6 squared plus 4 squared, okay, which comes out to 4.3 meters per second, and then finding the angle is just trig, okay, 10 to the minus 1 of 1.6 over 4, which gives us our 22 degrees east of north. In walking around, that's not the part people are struggling with, and it's not the part I would expect people to struggle with. Okay? The part people are struggling with is part B, and it's basically the same thing. Every one that I've gone around and looked at that's had an issue with it has done the same thing, so it's important for us to clarify this because it is a very common mistake. They want to know if it takes us 3.5 minutes to row across, which we have to convert to seconds, by the way, so we might as well do that first. Okay, so 3.5 times 60, okay, is 210 seconds. Okay, so I got 210 seconds as my time. Okay, if it takes me that long to row across, how far downstream do you end up? And so the mistake I'm getting, or the question I'm getting asked is, well, what do I use to calculate that? Well, first the time, and if I want to calculate how far, that's V times T. So the next question is, okay, I see I've got T, which V do I use? Well, the one that points in the direction they asked, downstream. Okay? A very common mistake is for people to use this V, because they've put all this effort into calculating it. They figure it can't just be done, I must have to use it again. But the answer is no, you don't. If it wants to know how far downstream you go, you've got to use a vector that actually points downstream. This green vector is your resultant. It points a little across and a little downstream, but not downstream. Okay? So I can only use vectors that match the direction I'm being asked for. Does that make sense? Okay, so I would use the 1.6. So I'd say if I'm moving at 1.6 meters per second downstream for 210 seconds, I will end up 336 meters downstream. Okay? I can't calculate that number without a vector that goes the same direction, or a vector quantity, sorry, that points in that direction. Any other questions on number 3? All right, give number 4 a try. It's a little more involved than I would ask you on a unit exam, but exactly the kind of thing I would ask you on an assignment. Okay, because you have a little more time for that. So give that one a try. I'll draw the diagram here in a few minutes. Okay, let's have just a look at the diagram here. So we got hiker lost in the woods, starts from her campsite and hikes 10 kilometers at 8.5 degrees south of west. Okay, so I'm going to draw a line that is west. I'm going to go 8.5 degrees south of that. Okay, and then from there, she turns and hikes 7.5 kilometers at 30.5 degrees south of west. So again, my reference is west, but now it's going to be a steeper angle, but not as far. Okay, so that's what my overall diagram should look like. Everything is south and west, so we don't have to worry about anything being negative because all the y components are south and all the x components are west. Okay, we just have to find our x's and y's, then our big triangle, and we're off. Okay, I'll give you a few minutes on that before I do the rest of it. Okay, so we got to find the x and y components for our two known vectors. Okay, so that's going to mean for the first one, we're going to go cos of 8.5 times 10 kilometers. Okay, so that's 9.89 kilometers west. Okay, and then our y will be the sine of that. So sine of 8.5 times 10 okay, is 1.48. 1.48. Okay, and that one is south. Then we got to do the same thing for the green ones. So for the green ones, we're exactly the same situation. X is going to be the cos because it's adjacent to the 30.5 degree angle. Okay, times 7.5. Okay, y will be the sine of 30.5 times 7.5. So cos of 30.5 7.5 is 6.46. And for our y, sine of 30.5 times 7.5 is 3.81. Okay, so now we've got all of our x's and y's. So if I want to calculate what red x is, okay, which is all west, I take my 9.89 kilometers west and add it to the 6.46 kilometers west, and that'll tell me how far west in total we went. So that plus that will give me 16.352 kilometers for x, and then for y, I'm adding them both as well because they're both south. Okay, so we'll have our 1.47 plus our 3.8. So we're looking at 5.28 south. Okay, and then we can do our Pythagorean theorem to get what d is. So that'll be the square root of 5.28 squared plus 16.352 squared. Okay, and that'll give us our 17 kilometers. And then theta will be opposite over adjacent, so tan to the minus 1, 1 of 16.3 divided by 5.2, right? And that'll give us our 18 degrees south of west.
Is it still fine if you do it the other way?
If you do the triangle the other way and got west of south, 72 degrees, you're good. Yeah. Okay. So obviously we don't have school tomorrow, so no Thursday quiz for you. You lucked out this week. No quiz this week. There will be one on Tuesday, okay, on vector addition. But Friday, like I said, we're going to work on our vector assignment. That'll be coming in for marks. Okay. Don't forget about your mapping activity. Okay, that's due next week. I'll give you way too much time for that, but whatever. I think I made it next week. Did I? No, I made it due Friday. Sorry, I made it due Friday. Friday, October 1st. That's Friday. Okay, so make sure you have that done for Friday. Sorry, I had it mixed up in my mind. The vector assignment we start Friday will be due Thursday of next week. Yes, it was. Okay, so you don't have a group then? Okay. Then, Marcus.
I think I know what I did.